Welcome back to our Getting Started tutorials and the second installment in the calculator series. This time we'll take a closer look at the Diffraction Angle Calculator, which does pretty much what it says on the tin. It calculates, by means of a grating equation and a series of input parameters about the incoming radiation and the grating, the angle of the emanating diffraction orders, both transmitted and reflected. Let us go through it carefully. If we take a look at the grating equation, assuming the unknown is the emanating angle, and in order to obtain an unambiguous result, we need to provide the calculator with the following information: the refractive indices of the incoming and outgoing medium, the angle of the incident radiation, the number of the order we are interested in, the wavelength of the incoming radiation, and the grating period. Sure enough, if we go to the form, we encounter that all these are required in one way or another. The first text box we come across asks for the grating period. There is no need to elaborate here. The user themselves can try out different values for the grating period and see how that affects the resulting diffraction orders. Then we go on to the incident angle. It is by default 0, which translates as normal incidence. If we modify the value of the incident angle, we see this green line in the diagram, which, as we can read below, represents the incident wave, shift to the new position. Evidently, the new incoming direction will also affect the outgoing ones, reflected in red, transmitted in blue, as per the legend. In the wavelength text box, the user should type the value of the vacuum wavelength of the incoming wave. The next stage in the controls allows you to fix how many orders you would like to have shown. You would be determining the value of the M you want represented. And here, VirtualLab provides a small cheat sheet with a maximum index for propagating orders under the current circumstances. I'm afraid you cannot go beyond that. This calculator does not show the evanescent orders. Finally, we come to the specifications of a media on both sides of a grating. First material refers to the medium where the incoming and reflected orders will propagate, and second material is for the transmitted orders. It is possible for the user to type either a constant refractive index or select a material from a catalogue, which it is then also possible to modify. This manner of dealing with materials through the catalogue is fairly common in VirtualLab, so we direct you to the corresponding tutorial for more information. Evidently, fixing the material on both sides of a grating determines unequivocally the value of the refractive indices for the pertinent wavelength. The Switch Materials button will swap the two materials so that the one on the side of the incoming radiation is now the one that was before on the transmitted side, and vice versa. Now all the parameters of the diffraction equation are accounted for, so we can turn to the output. The graded wheel provides a visualization of the different angles. If you would like to obtain this diagram in a new window, you can click on the Separate Diagram button. If you are in the mood for more analytical results, you can switch over to the Table tab in the calculator, where you will receive the same information in table form. You can also copy all or part of this table in order to paste it onto your favorite spreadsheet application. That's all for now. If you have any questions, please don't hesitate to contact us.